Hi, everybody. Mr. McCarson back with Measurement and Calculation Notes Part 2. Today, what we're going to do is learn a skill that we need more high school graduates to be very proficient at, and that's learning how to read numbers with significant figures off of a ruler. One of my kind of sad realizations I've had as a high school teacher now for 18 years is that we need to have our students graduate high school with fundamental skills that will help no matter what you do in life. And one of the things I've noticed with young adults and even older adults in my own personal life is you give them a ruler or a tape measure or a meter tape, and you tell them to give the dimensions of something, and sometimes that can be disastrous. So, my goal for this lesson is two parts. First off, we're going to start discussing the concept of significant figures and what they mean as they pertain to reading measurements off a scientific tool. And we're going to start with one of the most fundamental, the ruler. Okay. So we're going to learn how to read significant digits off a ruler based on the smallest lines of measurement on the ruler. Because one of the things you're going to learn in chemistry and in advanced laboratory scientists and just in life is not all tools of measurement are equal. Some are more accurate and precise and allow more precision. Some are not very accurate at all and have less standards of precision. So that's going to be important. Then we're going to learn about the concept of the significant figure, which is also known as sig figs. So if you hear sig figs, that's just kind of a goofy chemistry shorthand for talking about significant figures, and how to properly record numbers in sig figs that we read from a scientific tool, such as a ruler, meter tape, graduated cylinder, Erlenmeyer flask, beaker, digital balance, etc. Okay, so really big topic. It's our first step into a new world. Many of you have used tape measures before, doing things at home, maybe in the garage with your parents. I'm going to show you a little different way to look at the measurements we take from those tape measures numerically to record your quantitative data. So thank you for being here and joining me on this journey, and let's get started. All right, everybody. So the first thing we need to talk about with significant figures is their basic definition, which a significant figure is how many digits or what digits within a specific quantitative measurement mean something, mean that they are important to the understanding of the overall value that's being expressed by the measurement. Okay. So when we measure something, we can and do estimate between the smallest lines of measurement in our measuring device. So for example, if you look at a ruler, you're going to see the smallest lines on whatever size ruler that is. And for the human eye, we have a pretty accurate eye. It's very sharp. We're trying to look, where does the object that we're measuring end up in relation to the smallest lines of measurement on the ruler. So let's kind of take a look at a basic example for that here. So here we have a ruler, and the first thing I want you to notice about the ruler, and what you should always analyze about any ruler that you're using, is you want to look at the units of measurement that it's, or not the units, the numbers in the lines of measurement that you're beginning with. So if we look at this ruler, it's pretty basic. Every line is counting up by ones. Okay, so every line counts up by ones, and we go from 1 to 5. Okay, now let's go ahead and enter a line. So here's an object that we're going to measure. And here's kind of the basic concept. Significant figures are the digits that we absolutely know about the measurement. Okay, it is the numbers in the ruler that we know with 100% certainty that the object is going to measure at least the amount of. Then the other sig figs are what we call the estimated digit, which is where does the line that we're measuring in this example, where does it end between? And there might not be a line for us to like actually see it stop on, which is okay because we're going to estimate. So we're going to look at the distance between the line we absolutely know and the line that it doesn't quite get up to, and we're going to provide what we call the estimated digit. So let's take a look. When we take a look at this line, what number does the line absolutely cross? Well, if we look here, it absolutely crosses the 4. Okay, now ask yourself, does it get to the 5? No, it doesn't. So we know that the object we're measuring is absolutely going to have a number of 4. Okay, now we don't know the units. It doesn't really matter here whether it's inches, centimeters, meters, kilometers. We know that it's definitely 4 because it passes that line of measurement. And we know it's definitely not 5. Okay, we cannot say that it's 5 because clearly we see here there is a gap. So what we have to do now is we have to come up with an estimated digit to represent where we think it lies between 4 and 5. So kind of think about that for a second. I'll pause for a second. Think about that. Where does this little green bar, where does it end between 4 and 5? And if we think about um, number places in our place value system, if we're counting by ones, okay, we're in the ones position, we need to go one number place smaller in the number position line, which would be the tenths, right? So if we look at this, to me, it looks like it's about halfway between 4 and 5. Okay, that's what it looks like to me. Now, if it's halfway between 4 and 5, I want to express that as a decimal in the tenths position. So what would be an appropriate estimated digit I can put here? Well, I'm going to put my decimal, and then I would say half is represented by the tenths of a 0.5. So we have the known digit here, which is the 4. We absolutely know the 4 is significant because we can see it crosses that line, okay? And then for the 0.5, this is known as our estimated digit. It is where the measurement ends between two lines, so we're estimating that, okay? Now, both of these are considered significant digits, okay? They're both significant figures. So if you asked how many sig figs is in the measurement for this ruler, the answer would be 2. The 4 is significant, and so is the 0.5, which is our estimated digit, okay? So, and this would be your known digit, though that's absolutely indisputable, okay? So this is kind of a basic idea of how we use a ruler to look at and figure out the estimated digits and the known digits. And it changes depending on how accurate, which means how small your lines of measurement get. The smaller the lines of measurement, the more accurate you can get, but you'll still always have one estimated digit at the far right of your measurement in the rules of sig figs and reading things on scientific measuring tools. Okay, now let's extrapolate with this example. Now keep in mind, this is the same bar that we used in the last example. Same bar, right? So this green bar is the same size as before. However, take a look. What's different in this example? Instead of counting by ones, the smallest lines of measurement now are 0.1. So we have 0.1, 0.2, 0.3, all the way up over here to 0.9. The line here in the middle would be 0.5. So this is the same size ruler, but it's more accurate because it has smaller lines of measurement, more accurate lines of measurement that lie between the 4 and the 5. So this ruler counts by 0.1, right? So it counts by tenths. Now, the better the marks, the better we can estimate the actual measurement, the more significant digits we're able to produce in our measurement, okay? Scientists always understand that the last number measured is the estimate, right? We know that as the estimated digit. So let's take a look here. So let's go through the numbers that we absolutely know that this ruler covers. So the first line is still 4, so it's absolutely going to go through 4. And then if we take a look, we go 0.1, 0.2, 0.3, 0.4, and here's 0.5. And if you look carefully, the line goes a little bit beyond 0.5, but it absolutely, at least in my eye, and I hope it does too in yours, it absolutely crosses 0.5. So here 0.5 is a known digit. Now, we have 0.6 next. And does the green line quite make it to 0.6? I don't think so. Now, our eyeballs are very sharp. We should be able, unless you're Mr. M, because I played far too much PlayStation and Xbox and PC in my life. Oh, and Nintendo and original SNES and Game Boy, which I still have my original one. So in any case, your eyes, unless you have fried them like Mr. McCarson playing too many vids, your eyes should be able to tell an estimate on where you think this little line ends between 0.5 and 0.6. Does anybody have an idea on where that ends? To me, it looks like it ends halfway between 0.5 and 0.6. So I'm going to now have an estimated digit of another 0.05. I'm saying it's halfway between 0.5 and 0.6, which would be 0.55. Now look, the 4.5, these are known digits, right? Those are significant. And then this last 5 on the end, this is your estimated digit. Now, because this is a better ruler than what we had in the previous slide, this now contains 3 sig figs. So in this measurement, this ruler is significant up to the 100th spot, right? And we would say that for this measurement, there's 3 total significant figures. Oh, hi everybody. So let's move on to another example. The measurements we write down tell us about the ruler we measure with, right? So one of the problems is many young students, when they first get into this, they tend to look at a ruler and they think they're reading the number off the ruler correctly, but they don't write it down correctly because they're not thinking about sig figs and the smallest lines of measurement on the ruler that they're using for their activity or whatever process they're going through to measure. Okay, so remember that the last digit is considered significant and it's always going to lie between the lines. Your last digit you record should lie between the lines. And we'll talk about what to do if your eyeball thinks it ends exactly on a line. We'll talk about that in an example here. So it says, what is the smallest mark on the ruler that measures 142.13 or 0.13 centimeters? So here we go. Now, when we take a look at this ruler, if we want to get something that says 142.13 centimeters, my question is this current ruler good enough? And if you take a look at the lines of measurement, it goes 141 to 142. So what would be the highest measurement we could get here? We actually couldn't get this measurement. So it would not be proper to use this ruler to get 142.13. Here's why. We know that the lines of measurement, the smallest lines count by ones, the ones position. And we can see this bar absolutely goes beyond 142. So we can say with certainty that 142, 1, 4, and 2, these 3 numbers are all significant. However, do we have little lines counting by 0.1 in this example? Do we have 0.1, 0.2, 0.3, etc.? We don't. So because we don't have any smaller lines than the ones position, there's no way that you could accurately represent this number of 142.13 with this ruler. Now, what would be an acceptable measurement here? If we think about this little chunk as our estimated distance, we have to think about it between 142 and we're assuming the number 143 is over here on the other side, blocked by this mug that's in the corner of your screen. Blocking the screen as always, getting in the way, Mr. M. Now, what I would say is for me, I probably look at that and go, okay, the best I would say is 0.1. I don't think it would be 0.2, so I would say it's about 0.1. And this would be an appropriate estimated digit. So for this particular ruler, the most sig figs I could have based on the estimated value would be 142.1, so 4 total significant figures. And the estimated digit here would have to be the tenths spot. So the tenths place would be considered my estimated digit if it is accurate, if the lines of measurement count by the ones position. Remember, you're always going one spot smaller on our number sequence, right? So from ones to the tenths, from tenths to the hundredths, from hundredths to the thousands, or from hundreds to tens, okay, if it's not a very accurate measuring device, like our beaker or Erlenmeyer flask. And so we actually couldn't get this number for this particular example. Okay, so let's take a look at another example. On this one, it wants to know what is the smallest mark on the ruler that can measure 142 centimeters. So let's take a look here at our ruler in question. So we've got our line, this white bar on top, and then we've got our green ruler. And if we take a look, we got 100, 150, 200. But then if we take a look at the smaller numbers in between, right, this looks like it's 110, 120, 130, 140, and then it goes to 150. Now, if we're thinking in terms of sig figs, okay, what we're seeing on this ruler is we're counting by tens this time. So the smallest line increments are increasing by 10 for each little line for the smallest lines in the ruler. So what is our absolute certain number that we cross, right? So we absolutely cross 140, right? Now, we absolutely cross that, but here's the trick. This 40 is a little problematic, right? Because we're not going to put a decimal here because we're not counting by ones. To put like a 0.1, 0.2, 0.3, the smallest lines on our ruler would have to be in the ones position. Here they're in the tens. So what we're going to actually do is we need to get rid of this 0 and change the 0 to an estimate. Now, if we take a look, it absolutely crosses 140, but it doesn't go to 150. And so we could estimate, and you might take a look at this and say, hey, when I estimate this ones position, it's about 142 centimeters. Okay? Now, that means that this ruler would actually be appropriate to get this measurement, right? If you're going to end with an estimated digit in the ones, what that means is the smallest lines of measurement in your overall ruler should be the tens because you're estimating between the tens lines, right? That's where this 2 comes in. It's the estimated digit. We absolutely know it's 140, and then the 2 at the end is our estimate, right? The 2 at the end is the estimated digit. And so I think that this ruler is appropriate to get a measurement of 142 centimeters. You wouldn't put a decimal place here. Why? Because we're not counting by ones. The smallest lines are not incremented by 1, okay? You wouldn't leave it at 140. Now, if you wanted to get 140, what that means is it would end right on the line, okay? And how you would do that, let's say that this ended right on the line, how you would write that to show that on this particular ruler, if this white bar stopped right on 140, you would write 140 and then put a decimal point. If you put a decimal point, what you're saying is that it ends on the line. Okay? Some students are like, do you need to put a decimal point or not? Decimal points are a very big deal in chem. If you put one, it says something about the significance of your ruler, right? If you don't put it, it also says something. So that is a big deal for us, is if you add that 0, it means that you're ending right on the line. So the 0 is an estimated digit. You're saying it ends on the line, period, end of discussion. Okay? Everybody got that? All right, cool. Okay, everybody, so thank you for sticking with me thus far. I know this is kind of weird. It's a very obscure topic, but it's really important. Like this will go with you far. You go into physics, you go into more advanced college lab classes, you go into engineering, architecture. high craftsmanship. So you go into things like electricity, plumbing, um, framing, masonry. Like significance in measurement is a really important thing to me, and I hope you all are following along and not hating this lesson. I appreciate you being here. And by the way, if you are feeling like you're getting something out of this content, subscribe or a like on the video would be much appreciated. Thank you. Um, I humbly am thankful that you're here with me going through these lessons. And I just want to be the best I can be for you here is to help you get through any difficult classes that you're going through in science in your life. Okay, so here's a problem. Here we have the same line twice. Okay, that we'll end with this slide. Um, the measurement is 140 centimeters. Okay, now the problem is this. If we look at the top ruler, it's better. Why? Because it's counting by tens in its smallest increments. So we got 110, 120, 130, 140, and then 150. Okay, now when we look at it, this ruler, it looks like it's ending right on 140. Okay, now for this ruler, because we count by tens, we want to estimate to the ones position for significance. So an appropriate way you could write 140 with this ruler is 140. Now because this ruler is counting by tens, and it ends right on the line for 140, we could put a decimal place here to tell the reader of the number, boom, it ended right on that line. Okay, it ended right on that line. Now, the problem with the bottom ruler is it ain't so accurate. It's not very accurate. Here we're counting by hundreds. And so if you count by hundreds, what you have to do is estimate to the tens position between the hundreds position. So for the bottom ruler, if we say it's 140, the estimated digit is not the 0. The estimated digit here would be the 4. We can't have the 0 as a significant figure because we're not counting by tens. The only digits we know for certain are the 1, because it's absolutely guaranteed that we cross the 100 mark, right? That 1 is in the 100 spot. Now, the 4 is our estimated because we think it's about 40, okay? The problem is this 0 on this ruler is not significant. So the 0 here is not a sig fig. And if I put SF, that's just me shorthanding for sig figs because I'm not very tactile with my mouse as a pencil. Now up here, because this one counts by tens on the top ruler, and we know it ends right on the line for 140, and we put a decimal, this 0 is a sig fig. So one of the things we're going to do in the next video lesson is we're now going to officially start to learn when we have a measurement, what zeros within our overall quantitative measurement are considered significant and what zeros are not. Okay, so here's the problem once again with these rulers. Is the 0 in the top ruler versus the bottom ruler significant? And I'm going to teach you those rules in the follow-up video to this when we do part 3 on the actual rules of sig figs. All right, so in conclusion, what did we learn about rulers today? When you measure something on a ruler, you're always trying to ascertain what the smallest lines of measurement are in the ruler. So like this top ruler, the smallest lines of measurement are by 10. In the bottom ruler, the smallest lines of measurement are by 100. And what you do is you can only write your answer for the measurement, your observation of the quantitative value, by estimating to one digit smaller than what the ruler measures. So once again, if you count by tens, you're going to estimate to the ones position, and that will be significant. If you count by hundreds, you can only estimate to the tens position, and so the hundreds and the tens position will be significant, but not the ones. because we don't know for certain if it gets to that line. We don't have a good enough ruler. So overall, sig figs are designed to have us understand how accurate our rulers or our measuring scientific tools are in not just chemistry, but in physics, in professional industrial settings. No matter what you're doing in life, sig figs are there. You might have not thought about it till now, but I hope that you do think about it from this point forward. And I hope you enjoyed the video, and thank you for getting through the lesson. And we're going to do a lot of measuring now that you understand this and put it into practice. All right, everybody, take care. Have a great day, and I'll see you in class.